Hello everyone, I am Dr. Samyukta S, Assistant Professor, Department of ECE at SJBIT. In this video, I am going to explain you about the rectifiers. See, rectifier is a semiconductor device that commonly used to convert an alternating current to direct current. Okay, so there are three types of rectifiers: half wave rectifier, full wave rectifier, and bridge rectifier. So half-wave rectifier consists of a single diode. Full-wave rectifier circuit consists of two diodes, whereas bridge rectifier circuits consists of four diodes here. Okay. So half-wave rectifier consists of a single diode. It operates only on either positive or negative half cycle of the supply, hence it is known as an half-wave rectifier. Okay, so that is during the positive half cycle of AC input, the diode is forward biased and hence current flows through the load resistance RL. Means D1 will be in an on state. Okay, so but during the negative half cycle of the AC input, the diode is reverse biased and hence no current flows through the load resistance RL. That is D1 will be in an off state. So thus the current flows through the resistance RL only during the positive half cycle of the AC input. Hence it is called as an half wave rectifier. Okay, so it is called as an half wave rectifier because it will going to work only for the half cycle of your input signal. Either it may be a positive half cycle or it may be a negative half cycle. Fine, so next one is the full wave rectifier. So this is the circuit of the full wave rectifier. So as I told, the full wave rectifier consists of two diodes, that is D1 and D2 here. So through the transformer we are giving the sinusoidal input to the full wave rectifier and the output is measured through the load resistance, that is RL. Okay, so here the diagram A is representing the output when you supply the positive half cycle of the input signal, and the circuit B is representing the output when the negative cycle of the input signal is supplied to the full wave rectifier. Okay, so full wave rectifier uses two diodes, a load resistance RL and a center tap transformer as shown in the figure. So center tapping here is in the secondary winding of the transformer is done to obtain two equal voltages. Okay, so in order to obtain the two equal voltages but both are of opposite phases. Okay, so we use a sense tap transformer here. So let us see how it will going to work. See, during the positive half cycle of the AC supply, that is when we send the positive half cycle of the sinusoidal signal to the full wave rectifier, the voltage at point A is positive and point B is negative. So point A is representing the anode point of D1 and point B is representing the anode point of the D2. Okay, so therefore diode D1 conducts as it is forward biased and D2 is reverse biased, remaining in off state. Okay, so when you apply the positive voltage at point A and negative voltage at point B, since we are applying the positive voltage at the anode of D1, D1 will be in forward biased condition, and we are applying the negative voltage at the anode of D2, so D2 will be in a reverse bias condition. So D1 will be in an on state and D2 will be in an off state here, hence the current flows through the load resistance RL. Since the current flows through the load resistance RL, obviously we'll get the output voltage V0 at that particular point. So during the positive half cycle of your AC input, the full wave rectifier will going to work like this. Fine, but during the negative half cycle of the AC input, the voltage at point C is positive and point B is negative. Thus, D2 is forward biased and D1 is reverse biased. Now it is complement operation. So because of which hence the current flows through the load resistance RL here. So during the second half cycle, D2 will be in an on condition and D1 will be in an off condition, but still the current flows through the load resistance RL Hence, we get the output across the load resistance RL in the second half cycle of your input signal also. Hence, the current flows through the load resistance RL in both the cycles of the input AC supply, isn't it? So, in both the positive and the negative half cycle, the current is flowing through the load resistance RL here. Hence, it is called as a full wave rectifier. Okay. So, now if I connect the capacitor in parallel to the load resistance RL, that is, let me name it as C1, capacitor C1. So C1 is added to ensure that the output voltage remains same or near the peak voltage even when the diode are non-conducting. Okay, it changes to approximately 16.3 volts at the peak of the positive half cycle and holds the voltage at this level when the diodes are in their non-conducting states. The time required for C1 to change to the maximum level is determined by the charging circuit time constant. The time required for C1 to discharge is more. The discharge time constant is determined by the capacitance value and the load resistance RL here. Okay. So figure shows the voltage waveform for the biphase rectifier with and without capacitor present. Okay, so in this circuit, secondary winding resistance is formed by two series resistance here, and the C1 charges very rapidly as soon as D1 or D2 starts to conduct. So here the load resistance is very much larger than the resistance of the secondary circuit, hence the capacitor takes more time for discharging here. Okay, so during this time D1 and D2 will be reverse biased and in non-conducting state. Therefore, the only discharge path for the capacitor C1 is through the load resistance RL. Okay, so this is how the full wave rectifier will going to work. So next type of rectifier is the bridge rectifier circuit. So this is the bridge rectifier circuit. So as I have already told, the bridge rectifier consists of 4 diodes here. Okay, so all the 4 diodes are connected to form a bridge here. So the AC input applied to the diagonally opposite ends of the bridge. The load resistance is connected between the other two ends of the bridge here. Okay, so during positive half cycle, so whatever I told here, it implies to this particular diagram. So here all the 4 diodes are arranged to form a bridge here. So two diagonally opposite ends are connected to the load resistance and to the remaining two diagonally opposite ends of the bridge circuit we are supplying the input here. So the AC input applied to the diagonally opposite ends of the bridge here. So the load resistance is connected between the other two ends of the bridge. Okay, so during positive half cycle of AC input, point A is positive with respect to point B here. Therefore, D1 and D2 are forward biased while D3 and D4 are reverse biased. Okay, so the current flows through the path C, D1, EF, D2, DC here. So during negative half cycle of AC input, point B is positive with respect to point A here. Hence, diode D3 and D4 are forward biased while D1 and D2 diodes are reverse biased. Hence, the current flows through the path in which the diodes D1 and D3 and D4 are connected here. So during both the half cycle of AC supply, load current flows through the load resistance RL, hence IL is unidirectional. Whatever the current that will going to generate, that is the load current is unidirectional here. Okay. Suppose if I connect the capacitor, one capacitor in parallel to the load resistance here. So C1 is added to ensure that the output voltage remains same or near the peak voltage even when the diodes are non-conducting. Fine. It charges to approximately 16.3 volts at the peak of the positive half cycle and holds the voltage at this level. When the diodes are in their non-conducting states, when they are not conducted. The time required for the capacitor to charge to the maximum level is determined by the charging circuit time constant. So as I've already told for the full wave rectifier, the concept remains same here. The time required for C1 to discharge is more. The discharge time constant is determined by the capacitor value and the load resistance RL. Okay, so here in this circuit, secondary winding resistance is formed by two series resistance here. Hence, capacitor charges very rapidly as soon as D1 or D2 or D3 or D4 starts to conduct. Fine. So the load resistance RL is very much larger than the resistance of the secondary circuit. Hence, the capacitor takes more time for discharge in. So during this time, D3 and D4 will be reverse biased and in non-conducting state. Therefore, the only discharge path for the capacitor is through the load resistance RL. Okay, so this is how the bridge wave rectifier will going to work. Thank you.